Hi girls, this is the screencast on 3.2 Combining Forces, and I'm just going to stick to the main crux of the lab just to give you a heads up before you start it. There's a blue question, the very first blue question on page 53 is the one that I'm going to focus on most. So it says, how does each vector formed along the diagonal of a parallelogram compare with the original vector that was not used to make that parallelogram? Now I know that sounds, ridiculous, but I'm going to break it down for you and hopefully help you figure it out. So again, this is 3.2 Combining Forces. And again, just to review, if something is stationary, the forces that are acting on it are then balanced. No movement, we have balanced forces. So you're going to create a situation in the lab where you have three forces acting on an object. You're going to pull on this object using three spring scales until the object stops moving. So you're going to have a picture then of three forces, which I'm going to draw now. So you're going to have a force in this direction, you're going to have a force in this direction, and another force in this direction. And so the object itself, of course, is somewhere in here in the middle, and these three forces are being exerted on it. And if you look at the figure on page 52 in your textbook, you can see what I'm drawing. So we're going to label our forces A, and this one is B, and this one is C. And what we're going to do is we're going to use two forces out of these three to make a parallelogram, and then look at the diagonal of that parallelogram and compare it to the first force, the force we didn't use to make the parallelogram. So it's super, super simple. So the first thing that you do is we're going to pick force B, and we're going to copy it. So we're going to take force B, and we're just going to move it over here, try to keep it at about the same angle, and again, I would be using a ruler. I'm actually going to I'll use the drawing tools. So we've copied force B, and now I'm going to copy force C in order to make this parallelogram. So if I copy force C, I come over like this. I'm going to put my pen back on. Okay, so in other words, this is the copy of C. You can see it's about the same length and about the same in the same angle. And this again is the copy of B. And we do this in order to make this parallelogram. You can see parallelogram is basically a rectangle made with four sides, two of which are parallel, and the other two are parallel. So the diagonal goes from one point of the parallelogram to the other. So I'm going to make this diagonal a blue shape and put the head of the vector over here. And so the original question is, how does this diagonal compare with the original vector that was not used to make the parallelogram? Well, the vector that was not used is this one, vector A. We're seeing how does this compare to the diagonal of the parallelogram. Well, I don't know if you guys can see that, but basically those two vectors are equal and opposite, which they would have to be, wouldn't they? Because if an object is experiencing this force, force B, and force C, and the object is not moving, it must be balanced then by an equal and opposite force. So in other words, the sum of force B and force C is this diagonal force, which is equal and opposite to A. So to answer that question, how does the vector formed along the diagonal of a parallelogram compare to the force not used to make it? That vector is equal and opposite in direction. Good luck with the lab. Okay, and my joke, let's see. How can you tell if, I guess this is not really appropriate, but it's something from when I was a kid. How can you tell if a blonde has been using a computer? You'll find whiteout all over the screen. All right, there's my joke. And again, no promises that it was going to be funny. Bye.